Hello viewers, in today's session we are going to discuss a very important and conceptual problem from limits, right? And here we have to evaluate this limit, that is limit x tends to 1, and we have the function x cube minus greatest integer of x divided by x raised to 4 minus greatest integer of x, right? So here we'll see whether the limit of this function involving the greatest integer function when x tends to 1, it exists or not. So for the existence of limits, what we will do, we'll find out the right hand limit and the left hand limit of this function when x tends to 1. Right? So first we'll find out the right hand limit and then we'll find out the left hand limit. Now before finding out the limits, let us quickly revisit this function, that is greatest integer of x. Right? Now see, greatest integer of x is defined as greatest integer of x is greater than or equal to n and less than n plus 1, where n is some integer, right? So for instance, if we take say x is equal to 2.5, then what is the greatest integer of 2.5? So this is obviously 2, because 2 is the greatest integer less than 2.5, right? So we can use this inequality to illustrate this expression. So we have 2 here, n is 2 because this is n. So we have n less than or equal to, here we have greatest integer of 2.5 and here we have 2 plus 1, right? So we can write now 2 less than, here we have greatest integer of 2.5 is simply 2 and here we have 2 plus 1, 3, right? And similarly, if we have a negative number, say minus 1.5, right, then the greatest integer of minus 1.5 is equal to minus 2, because minus 2 is the greatest integer less than minus 1.5, right? So writing this expression in terms of this inequality, we can now write minus 2, then here we have less than or equal to greatest integer of minus 1.5 and here we have minus 2 plus 1, right? So we have minus 2 and here less than or equal to this expression is minus 2 and here we have minus 1, right? And we know that the greatest integer of any integer, say greatest integer of 2 is simply 2 and greatest integer of minus 2 is minus 2 and greatest integer of 0 is 0, right? So let us come to our problem and let us find out the right hand limit. So the notation for right hand limit is limit x tends to 1 and here we put a positive sign and here we have the function f of x. So we can take this function as f of x. So now what we will do, see here we have x is equal to 1 and we'll take 2 points in the neighborhood of x is equal to 1, one towards the left and one towards the right. So the left point or the left neighborhood is given by a 1 minus h and the right neighborhood is given by 1 plus h, right? So when we approach towards 1 from the right of x is equal to 1, then we have this point 1 plus h, right? So we'll do x is equal to 1 plus h. So we'll make this substitution, and when x tends to 1, then obviously h tends to 0, and this quantity h is infinitesimally very small, right? And this is greater than 0 and 1. So h is a very small quantity. So now writing this limit in terms of h, so we have right hand limit as limit, and here for x tends to 1 we have now h tends to 0, and we can write f of x, x is 1 plus h, right? Okay, so now we'll substitute 1 plus h in this expression. So we have limit h tends to 0, and f of 1 plus h can be obtained by replacing x by 1 plus h. So we have 1 plus h cube minus greatest integer of 1 plus h, and here we have 1 plus h raised to 4 minus greatest integer of 1 plus h, right? So now we have to evaluate this limit. See, whenever we come across with functions like greatest integer function or fractional part function, we cannot directly substitute h, the value of h as 0 over here, right? So what we do, we make use of the definition of greatest integer function. Now let us consider this quantity. So see, 1 plus h. Now see, here h is infinitesimally very small, right? So when we add h to 1, then the value of this expression 1 plus h is slightly greater than 1, right? But it remains less than 2. So by definition of greatest integer function, the greatest integer of 1 plus h should be equal to 1, because 1 plus h, this quantity is slightly greater than 1 and it is less than 2. So 1 plus h, it lies between 1 and 2. So the greatest integer that is less than 1 plus h is 1, right? So replacing this quantity by 1 and this quantity by 1, we can now write limit h tends to 0, and we have 1 plus h cube, and here we have minus 1, and here we have 1 plus h raised to 4 minus 1. So now we have this rational expression in terms of h. 1 plus h cube minus 1, 1 plus h raised to 4 minus 1. So now if we here if we take h is equal to 0, then see the expression becomes 1 plus 0 cube minus 1, and here we have 1 plus 0 raised to 4 minus 1. So this is 1 cube. 1 cube is 1, here we have minus 1, then 1 raised to 4 is 1, and here we have 0 over 0, right? So here we have 0 over 0 form, so we can easily apply the L'Hopital's rule here, right? We can also expand 1 plus h raised to 3 and 1 plus h raised to 4 by simply using the binomial theorem, right? But here we'll prefer to use the L'Hopital's rule. So what we will do by applying the L'Hopital's rule, we'll differentiate the numerator and denominator with respect to h. So the derivative of here we have d by dh of 1 plus h cube minus 1, and then we have d by dh of 1 plus h raised to 4 minus 1, right? Okay, so now the derivative of 1 is 0, and here also the derivative of 1 is 0. So the derivative of 1 plus h cube is given by 3 times 1 plus h square, and by chain rule the derivative of 1 plus h is simply 1. And here we have the limit notation, and the derivative of 1 plus h raised to 4 is 4 times 1 plus h cube, and here by chain rule the derivative of 1 plus h is 1, right? So now see, we have limit h tends to 0 3 by 4, and here this quantity get cancelled with this one, and here we are left with only power 1, right? So we have 4 times 1 plus h. So now taking h is equal to 0, here we have 3 by 4 times 1 plus 0. So this is 3 by 4, right? 4 times 1 is 4. So the right hand limit of this function when x approaches to 1 is given by 3 by 4. So let us find out the left hand limit. So the notation for the left hand limit is given by limit x tends to 1, and here we put a negative sign here, and we have f of x. So now when x approaches towards 1 from the left side of 1, then we come close to this point, that is 1 minus h. So we'll take here x is equal to 1 minus h, and again h is infinitesimally very small, and it lies between 0 and 1. And here when x tends to 1, then h tends to 0. So now expressing this limit in terms of h, the left hand limit is given by limit h tends to 0, and we have f of 1 minus h, right? Okay, so now we'll find out the value of f of 1 minus h by taking or replacing x by 1 minus h. So we have 1 minus h cube, then we have here greatest integer of 1 minus h, then we have here 1 minus h raised to 4 minus greatest integer of 1 minus h, right? Okay, now again the same thing, we cannot substitute directly h is equal to 0 in the expressions containing the greatest integer function, right? So what we will do, we'll separately find out the value of greatest integer of 1 minus h. Now see, in the, when we have calculated the right hand limit, we had 1 plus h. Here we have 1 minus h. So it means when we subtract h from 1, then this expression 1 minus h is slightly less than 1, but it is greater than 0, right? Because h is less than 1, so 1 minus h remains a positive quantity. But 1 minus h is slightly less than 1, but it is always greater than 0. So the greatest integer of 1 minus h should be equal to 0, right? Because the greatest integer less than 1 minus h is 0. So now we can replace this quantity and this quantity by 0 here. So we have the left hand limit, limit h tends to 0. We have 1 minus h cube minus 0. And here we have 1 minus h raised to 4 minus 0. So now we have simply limit h tends to 0. And here we have 1 minus h cube divided by 1 minus h raised to 4. So this quantity get cancelled with this one, and here we are with only power 1. So this is limit h tends to 0, and we have 1 over 1 minus h, right? Okay, now taking h is equal to 0, here we have 1 over 1 minus 0. So this is 1 over 1, that is 1. So the left hand limit is equal to 1, right? So this is how we can calculate the right hand limit and left hand limit. And here it is interesting to note that the right hand limit and the left hand limit both are finite, right? And both exist. So these two are a very important thing here. So the right hand limit and left hand limit both are finite and they exist, right? But they are not equal. So right hand limit is not equal to left hand limit. And the condition for limit to exist is that the right hand limit and the left hand limit should be equal to each other. Besides, they must be finite and they must exist, right? So the in this case, the right hand limit and left hand limit, although they are finite and exist, but they are not equal to each other. So we can claim that the limit of this function, it does not exist. It does not exist when x tends to 1, right? So this is how we can solve these type of problems.